Hi, my name is Stefan Schneider. I would like to talk to you today about digital fabrication. What you see here is a model design in CADwork, a platform that allows us to do not only 3D CAD design, but we also define a lot of production information in here. This house was a little bit a special house. We have like multiple elevations. We have everything is a little bit angled, everything is a little bit tapered. And we also have like a lot of different roof plans intersecting with each other. So design-wise, that was a challenge. The bigger challenge was it was also, which it is common today, a so-called hybrid home. What that means is we basically have a lot of steel parts in there. We have timber parts, we have timber frame components, like for instance that entryway here. We have like cloulam beams, we got like stairs and all kind of stuff. What that means for us production-wise is that basically all these parts are produced in different locations with different manufacturing equipment. We're dealing here with 12,000 parts, timber parts, steel parts. If I talk about steel, maybe I zoom a little bit over to the garage, and that gives you a little bit an idea what we have here. There's steel I-beams interlocking with engineered wood, interlocking with other building materials. So that kind of gives you an idea what you're dealing here. You can see the TGI choice. So what I would like to show you today is basically the main difference between just a nice 3D model like we know it from Revit and AutoCAD 3D and all these programs. CADwork is a lot different. CADwork is different in a way that we also have production information in it. So because of CADwork, we were, for instance, able to build that house with less than 5% offcut, which that is really not much if you think about how much wood is in there and how complex the house is. So typically the more gable walls we have and tapered stuff, the more offcuts we have. CADwork uses an optimizer to actually do that. You can see we also have a lot of information like here, supplier information, truck number, producer and so on already in here, and we can within the CAD already design or define process information, like what building type it is, or here process quality, what type of joints we want to have splinter free or not. So I would like to show you today how is it possible to export all these parts without programming them manually on a CNC machine and without having any shop drawings. So what we do here is I would like to show you maybe the entryway for right now real quick. What that is, I'll just show you this part. So we basically have a timber frame entryway with mortise and tenon and so on. You see that a little bit better once I go in that wireframe. So mortise and tenon, pegs, and just the usual stuff. So what we're going to do, we're going to send that to a so-called beam processor such as a Hundecker K2 machine. So if I go export machine here, for instance, I just pick the one I want. You can see CADwork supports most of the machines out there today. So we go choose a Hundecker K2, that's what we used, and then basically I can define here what processes I want, and then I can click on each part and it will automatically compare the geometry and add what I want. So I just go delete that again, I just calculate it and it will find that with one click. So that's easy enough. Once we have that, we're going to export that, and here you'll see once again within the CAD I convert that real quick. Okay, that's fine. Here we go. So need to save here. There's a lot of parts to save, so that's taking a little bit some time. I think I should already have my BVN file, which that's the file for a so-called K2 machine. I'm going to show you that machine. This is basically that beam processor I was talking about. So fully CNC controlled. I meanwhile should have here my BVN file. So I double click on that and we'll see every part of that entryway should be loaded to that machine now. By the way, this is also the terminal that the machine operator sees that. So if I go arrange for machine, this is exactly what he sees. So we see here we have every part, and just to give you an idea, so we have every process here is defined, again, like splinter-free operations are defined the way I had them set up in the CAD programs. I can rotate the part in the machine, I see the shape of the tenon, the mortise and everything. So just to give you an idea here, we're about like 4 or 5 minutes, to cut the part like that. So that's pretty good, that would take longer just to do the layout. So this is as far as for the timber frame parts. If we go back here, I show you the rest of them all again. The timber frame components are actually the easier part of it. Let's have a look at the walls. All the walls were panelized. We have in this house, for instance, 350 different wall panels. If I look a little bit closer here, you'll see all the hold downs are in there, all the anchor bolts. So if I click here, it tells me this is, for instance, HDU8 in basement 22. These are anchor bolts, so all the plates will be re-drilled. You'll see that this little extension here is a notch for our plates. So what I want to do here, I want to show you a wall. So I just go in M6 and grab one wall here. There's a wall, for instance. So few side views. So gable wall, with opening. What we do is basically all these panels are defined here with a nailing pattern. So when I export that, I go again, export machine. This time we use a so-called fully automated panel line from type Weinmann. There's a multifunction bridge and framing station. And you'll see here, again in the CAD, I can define, depending on my type of OSB, what kind of nailing I'm using. So we're going to use the nail gun number 20, which is straight nails. I also have nail guns for staples and so on. So we export that. Basically, I create an NC file here for this panel. Again, there's a lot of different options we have. So I'm just going to create that real quick. Meanwhile, I'll show you where we want to send that. So this is a Weinmann multifunction bridge here. Basically, nail guns, router head, maybe multiple nail guns. This is like a little bit an easier line without a floor line. So this is same thing. So what we feed in is we feed in lumber, and we will have a panel, nailed and routed with the spec we have in our CAD system. So again, meanwhile, yeah, here we go. So I got that NC file now, which is a so-called whoop file. So I go in here, and I will have this wall here on my machine. So I go here, will show me all these nails. Every point here is a little nail. You'll see around the window opening, I have a closer nailing pattern, and so on. So this is basically the export for these wall lines. So this panel here again is produced on that line. Like we got 3D data here as well, and the blockings are in. So I don't need to do a shop drawing for any panels. The last thing I want to show you today too, this is a little bit special, and a lot of people didn't think that would actually be possible, but we had some huge glulam beams in that house, and we couldn't feed them through a beam processor. So what's special here with that glulam beam is we have a compound cut on an arch and the flat spot on top. And this is an expensive glulam beam, so a lot of people thought, well, maybe we should just install the house first and then we cut the beam. What we did is we pre-cut everything off-site in the factory using a gantry type machine from type Chrono. There's also, like, for instance, Hundiger PPAs and some other machines are out there. So what that is a gantry type. You get a tool changer in there with a spindle, which basically that tool changer. I got a second picture here for you as well. This is the Weinmann, excuse me, that's not the one. There's a second Chrono. This is actually the machine on the Chrono. So here we got the spindle right now running a saw blade. There's other things too. Why would we use such machines? This is basically whenever we can't feed a part through a beam processor, that's what we're gonna use. So meanwhile, I got that model back in safety. I just want to show you real quick which beam I would like to interface for you. So if you look at the front, we have all these glulam arch beams. What's special about this one here is that one is cut with both roofs here. So that is like a really tough intersection. So we have an angle and a bevel cut here from the main roof and from the connector roof sticking towards my glulam beam. Okay, it's gonna take me a while. I guess I clicked too many times. Okay, so I'm just gonna, here it is. Yeah. Okay, so this is the beam I'm talking about. Just zoom in a little bit for you. So we have like angle and bevel cut. So basically, I show you that real quick. this is saved in my M5. So this is the beam. So flat, spot, angle, and bevel. You know, if you have here, you see a little bit better. That's basically my cut here. You know, front view, side view. So you'll also see that beam is not actually symmetrical. So every time if you have a situation like that, we use gantry type machines. So I'll export that one for you as well really quick. So we go this time export. We use a tool called LignaCam, which is right now the state-of-the-art cam software for beam or like for gantry type machines in the wood industry. So you know, we export that one beam. Again, individual control, we'll find a free contour which is already defined here. So export that as a BTL10 arch beam. Here we go. And now I should already have, when I go back here, I should already have this file. And we're going to open that with something called LignaCam. LignaCam is also a Swiss product used worldwide. Here we get a choice between different gantry type machines. I'm going to choose the Bollier & Sembra BC1, which is basically like 3 position wagons. We're going to load that file right now, and I would like to cut that for you here real quick. So file, we load that. I got my bow beam here. This is the part of the machine. You can also see the machine has these 3 position wagons with the clamps. So what I do here, it's already calculated. All these numbers just tell me what tools to use and whatnot. So we're going to make a simulation here, and I want to cut that part for you. So you see the bridge here. So I go, and now we can go through that code, and you'll see that machine. I'm going to run that a bit faster. We're going to pick the saw, make that bevel cut and angle cut. It has to make it like in a couple steps because the saw blade isn't that big, so we have to basically cut like a couple chunks at the time. So I'm gonna run that. So we pre-cut everything as much as we can with a saw blade, and then as soon as that is done, we're gonna go and grab a mill head so we can actually mill the contour really nice and smooth. So that's kind of how that all works. So yeah, I hope that gave you an idea, and you know, the next time if you do shop drawings, maybe think about me. There's easier ways to do that than going into 2D AutoCAD files. Thanks for listening, and talk to you soon.